Hello, this is Derdeen Muhammad. In this video, we are gonna talk about NumPy. We are still in the built-in functions in NumPy arrays. Here I ended the last video by aRange function. Even though the aRange function allows for float steps as zero point 0.3, the output is usually inconsistent due to the infinite floating point precision. For this reason, in case where non-integer steps are required, it is better to use linspace function. Linspace function uses a start, stop, and a number. This number we want it equally spaced between these two numbers. Here we will run. Here the start and stop are inclusive. They are included in the um, numbers. Here, if n, the number I stated here by 10, if n is not stated or not specified, it is by default specified to 50. Okay, here, this example, we will create a 1D array that has 10 integers equally spaced between 0 and 20. We will print the x. The syntax is np dot linspace between 0 and 20 10, and we will print also the shape, the type, and the dimensions. As you see here, the numbers are distributed between 0 and 10 is evenly distributed. The numbers are distributed equally between 0 and 20. The dimensions are 10. These are 10 numbers, and it's a NumPy array, and it's a float number. Okay, as you can see, because we didn't exclude 0 and 20. Okay, in this example, we will create a 1D array that has 10 integers equally spaced between 0 and 20, but with exclusion. I will exclude 20. How? By the same code, np linspace 0 20 10, first start, stop, and the number, and I will specify endpoint equal false. This means I will exclude the endpoint. And here, and as you see, because we changed excluded the endpoint, the spaces between the values has changes to fit 10 evenly spaced numbers. Okay, so 0, 2, 4, 6, and so on. Dimension is 10, and in the array and float. Okay, here we used so far, I used aRange and linspace function to create a 1D array. However, we can use these functions to create a 2D array by combining them with a reshape function. Reshape function, which is a function that gives new shape to an array without it changing its data. Here, we will create an array by using the output of aRange function as an input argument to the reshape function. Here, we will see how we will create a 1D array with sequential integers from 0 to 19, np.arange 20, from 0 to 19, because in arange the stop is excluded. Okay, we will print the original x, and then we will reshape x into a 4 multiply 5 in the array, columns and rows, and by the syntax np x equal np dot reshape x to 4 and 5. and then print the reshaped x and reshaped x with dimensions and the dimensions. And here it is. The original x are from 0 to 19, and the reshaped x are from also 0 to 19 by the dimensions of, as you see, 5 columns and 4 rows as we stated here, and the x has dimensions of 4 and 5, and x is an object of in the array and it's an integer. Okay, resulted in the same data with different shape. Okay, reshape can be used as a method. The same reshape here, it was a function because we had the output of here and used it as input in the reshape function. But from the great features of NumPy, it is that some functions can also be applied as methods. This allows the apply of different functions in sequence of just one line of code, as we will see here. And then this example, this example, we will create a 1D array with sequential integers from 0 to 19 and reshape it to a 4 multiply 5 array in only one code, one line code, the same as here, but here was x, np.arange 20 and np.reshape. Here np.arange 20, and here I used it as a method, not a function. Reshape 4 multiply 5, and we got the same result here from 0 to 19, and the dimensions are 4 and 5, 4 multiply 5, 4 columns, 4 rows and 5 columns, and here the same result. Okay, in the second example, we will create a NumPy array, a two NumPy array by using a reshape function. We will create a 1 in the array with 10 integers equally spaced between 0 and 50, with 50 excluded, then reshape it to a 5 multiply 2 in the array. How? np.lenspace 0, 50, 10 in point equal false, and reshape 5 multiply 2. Here we reshaped a np arrange. Here we will reshape a linspace arrange, and here it is, a 2 multiply 5, 5 rows and 2 columns from 0 to 50, 50 excluded, evenly spaced by 10, so we got it. And the dimensions and the class, the type, and the type of the object and the type of elements. Okay. Also, NumPy offers a variety of random functions to help creating random ND arrays of any shape. Random, we have 3 examples. The first example, random ND arrays are arrays that contain random numbers. We will create a random array that contains random numbers. This may be used in many things. Okay. Additionally, NumPy allows the creation. Here's the first example, which are often used in machine learning to create random matrices. Additionally, NumPy allows the creation of ND arrays with random integers within a particular interval. We will see in example 2. And in example 3, we may want to have a certain statistical properties to create random ND arrays with numbers drawn from various probability distribution, as we will see in example 3, sorry. So example 1, here we will create a 3 multiply 3 ND array with random floats in the half open interval from 0.0 to 1. The syntax is np.random.random 3 multiply 3, and we will print and see all. Here all the numbers are between 0.0 and 1 and distributed randomly, not with a given um, uh, um, sequence. And the dimensions are 3 multiply 3. The object is a numpy in the array and it's a float. Okay, the second example, as we said, we will create a 3 multiply 2 in the array with random integers in the half open interval. Here I stated the interval I want the random array between 4 and 15. Okay, np.random.radiant. Here not random, it's radiant because I stated the interval 4 and 15, and size is 3 multiply 2, 3 columns and 2 rows, and then 3 rows and 2 columns, and here they are from randomly distributed between 4 and 15, distributed randomly, not in a specific sequence, and in the shape and size I stated, and it's an integer. Okay, if we want, we sometimes need the random in the array to have average of 0 between certain statistical property, as we will see in this example. We will create 1,000 multiply 1,000 in the array of random floats drawn from normal distribution with a mean of 0 and a standard deviation of 0.1. Here will be np.random.normal 0, 0.1, and size is 1,000 multiply 1,000. And we will see the print x and the shape and the type, dimensions and type, and the elements, type of elements in x, and the mean, and maximum values of x and minimum values of x, and the negative numbers and positive numbers. X less than 0 dot sum to get negative numbers, and x more than 0 dot sum to get positive numbers, and to get a maximum x dot max and minimum x dot minimum, mean x dot mean, and here x has numbers all around 0. As you see, it's all around 0, normally distributed with the mean of 0 and standard deviation of 1. Here, x has dimensions of 1,000 multiply 1,000. X is an object of in the array. The elements in x are of type floats. The elements in x have a mean of, this is the mean, and the maximum value of x is 0.5 and the minimum value of x is 0.49. X has 499,756 negative numbers, and this is the positive numbers. As you will see, it's all around 0 and 0.1. Okay, how to manipulate data in ND arrays. We learned in the last video how to create and how to use built-in functions, and now how to manipulate ND arrays. ND arrays are mutable, which means that the elements in ND array can be changed after creating the ND array. Okay, in this example, we want to access individual elements of a 1D array. Here I will create a 1D array that contains integers from 1 to 5 in p.array 1, 2, 3, 4, 5, as we knew from the last video. Then I want to access elements with positive indices. Positive indices starts with 0, 1, and 4. 0 here is for the first number, is for the first element. The first element is takes an index of 0, and and so on, 0, 1, 2, 3, 4. So here it took 4. And then we will access the same elements from the negative indices. Negative indices means from backward. Negative 5, negative 4, negative 3, negative 2, negative 1. So, and then here, x is 1, 2, 3, 4, 5. This is first element in x, 1. We stated 0. So the output was 1. The second element is 2, as we said 1, and the last element is 5. And by the negative indices, here the first element took negative 1, negative 5, sorry, and then the last element took negative 1, 4, 5. Okay? And this is how we um, uh, access elements in an ND array. Okay, positive indices for accessing from forward and negative indices for accessing backward from the end. So in example 2, we will access how to modify. Here we will modify an element of 1D array. We will create a 1D array that contains integers from 1 to 5, and then we want to change the fourth element from 4 to 20. Fourth element, 0, 1, sorry, the fourth element to 20. So 0, 1, 2, 3. So x3 equal 20. And we will print x after modification. We will print original x and x after modification. And as you see, we changed the fourth element by its index 3 to 20. Okay, in this example, we access individual elements of a 1D array. How to access elements in individual elements in a 2D array? Here we must give the row and column of the element I want to access. This is the difference between the 2D array and the 1D array in accessing individual elements. We will access individual elements in a 2D array. We will create a 3 multiply 3 rank to ND array that contains integers from 1 to 9. And this is the array, and we will print it. And then access some elements in X. Here we want to access first element 0, 0, and we will see, and here it is. This is the original 3 multiply 3, 3 rows and 3 columns. 0, 0 index gives us 1. 0, 0 means first row, first column. 0, 1 gives 2. 0 is for the first row, second column. 2, 2 means second row, second column. Sorry, 0, 1, 2, sorry, third row, third column, because as we said 0, 1, 2, so it's the third row, 0, 1, 2, third column. Okay, how to modify elements in a 2D array? Here we modified elements in a 1D array, as we saw. How to modify elements in a 2D array? We will create a 3 multiply 3 rank 2 array that contains integers from 1 to 9, and then print the original x, and then change the 0, 0, first row, first column element in x from 1 to 20, and print x after modification. And sorry, the original x is as here, but we change it, the first number in the first row in the first column, to 20 instead of 1 by specifying the index of this number. Okay, how to delete elements? how to delete elements from arrays. Here in this example, we will see how to delete elements from a rank 1 array and how to delete elements from a rank 2 array. We will create our a rank 1 array and print it and then delete the first and last element of x. np.delete, as simple as that. X, to specify the array I want to change or delete from, and I specified the indices of the numbers I want to delete, and then we will print the modified x. In the 2D array, we will create the 2D array and print it, and then delete the first row of y. I want to delete the first row, np.delete, and then y 0, axis equal 0. The axis here is 0 because I want to delete the first row. The first row here, axis equal 0, and I said 0. While if I want to delete a column, a column, here I want to delete the first and last column of y. I will say x is equal 1. X is equal 0 is for rows and x is equal 1 is for column. Here np.delete also from y that I specified the array, and then 0, 2. The first 0 and the last 2. And here I specified x is equal 1 because here is a column and y is, and here is a row, x is equal 0. And then here the original x 1 2 3 4 5, I deleted the last element of x, which is 5. Here is deleted as I specified, and then first and last, sorry, first and last 1 and 5 deleted, and then original x is here from 1 to 9. Here I deleted the first row by specifying x is equal 0, and here I deleted the first and last column by specifying x is equal 1. Okay, how to append elements. Appending elements means adding elements to the end of an array. Here we will append numbers for a 1D array and a 2D array. In a 2D array, we must notice that the appending rows and columns must have the correct shape, as we will see. Here, append elements, create a 1D array, and this is the original, we will print the original x and append 6 for this array and print. And then append numbers 7 and 8, we will append 6 only, and then we will append two numbers. Here np.append x and 6 to specify the array I want to append to and the number I want to append. And then here for two numbers np.append x and between two brackets 7 and 8. While in the 2D array, here np.array, and I will create the 2D array and print it, and then append a row containing 7, 8, and 9 to y by np.append y 7, 8, and 9, x is equal 0. Here I want to append a row. While in column, we will append a new column containing 9 and 10 to y. Here I appended three numbers because I have three numbers in the row. While here I appended only two numbers because I have only two columns. So this is why the appending numbers must have the same shape of the rows and columns. In the appending column, I will state x is equal 1, and the numbers will be put added individually or written individually between brackets, not like the row. And then we will print the original x, and then x with only 6, and then x with 7 and 8. And as you see, when I modified or appended 6, The x is already modified. I didn't append it to and assign it to a different variable. Here, original y from 1 to 6, 1 to 3, 4, 5, 6, and then I appended the row 7, 8, 9, and then I appended the column 9 and 10. Here we appended the row 7, 8, and 9 by specifying axis equals 0, and the three numbers are between brackets. While in appending a column, I specified axis equal 1, and the numbers are individually between brackets. Okay, how to insert elements also in a 1 array and a 2D array. Here I will create a 1D array, np.array, and then I want to insert numbers 3 and 4 between 2 and 5 in X. In append, the appending number is added at the end of the array. While inserting, I want to insert certain numbers between certain numbers in the array. So I have the array 1, 2, 3, sorry, 1, 2, 5, 6, and 7. I want to insert 3 and 4 between 2 and 5. How? np.insert x 2. I specified the array of x and the number of 2, and then 3 and 4 between brackets. We will print x, and then we will create a 2D array, and then we will insert a row between the first and last row of y, between the first and last row of y. So np.insert y1. Why we specified 1? Because we want to insert the rows the row between the first and last row. The first row is 0, so I want to add a 1 row, so it will have the index of 1, and I specified the row and axis 0. While if I want to insert a column full of 5s between the first and second column, so I will specify np.insert y1 and 5. 1 because of it's the second column, and 5 the numbers I want to insert, and the axis equal 1. And here first we will see the 1D array. Original x is 1, 2, 5, 6, 7, and then I inserted 3 and 4 between 2 and 5. Here original y of only 2 rows, and then I inserted a row between first and last row, and here I inserted a column between first and second column full of 5s. Thank you, and see you in the next video.